So for problem number 15, it says calculate the energy necessary to bring together the charges in this configuration. So now, when we're going to talk about energy, we have some potential between 1 and 2. We have some potential between 1 and 3, and then some potential between 2 and 3. 1 and 2, 1 and 3, 2 and 3. Yeah, I think that's right. So now we got to add all that up. So the work is equal to the total or sum of the potential, which is equal to all these U12 plus U13 plus U23. And so if we want to know how to calculate U, you got to remember, and I'll write this off to the side, that U is calculated by the constant, and I'll write that down in a second, of charge 1 times charge 2 all over the distance between them. And this is the constant 9.0 times 10 to the 9th, and it's a goofy thing, Newton meters squared per coulomb squared. Okay. So we got to plug all that stuff in. So then this is going to be equal to, whoops, that. So we just need to know the charges, and they tell us the charges that's given to us. But the only thing is that we've got to convert these. So they give us micro coulombs. So remember that this is the Greek letter mu, which really is 10 to the negative 6. Okay? And then the distance behind them is 20 centimeters between all of them. It's an equilateral triangle. That means that the angles are the same, but that doesn't really matter. In this case, so we're going to say 0.2 meters. All right, so I'm going to do the constant K, which is 9 times, and I'm not going to write the units because I just don't have room on the board. So that's the constant K, and we're going to do the charge 1 to charge 2, so that would be 4 times 10 to the negative 6 times 4 times, or no, wait. If we do 1, 2, it would be 4. Oh, they're the same. Okay. 4 times 10 to the negative 6. Okay, that's the first one, divided by 0.2 meters. Okay, so that's this right here. I'm just plugging in the stuff, except I'm doing charge 1 and charge 2. Okay, so the next one, that's plus. The next one will be 9 times 10 to the 9th. And we're going to do charge 1, which is this right here, charge 1, which is 4 times 10 to the negative 6. And then between charge 3, which is a negative 4 this time, negative 4 times 10 to the negative 6 microcoulombs, right? And that's times 0.2 meters. And then we're going to add that plus 9.10, 9 times 10 to the 9th times. And so lastly, we're going to do 2, 3. So I'm going to take the charge of 2, which is positive 4, and the charge of 3. So I've got 4 times 10 to the negative 6 times negative 4 times 10 to the negative 6, running out of room there, all over 0.2. Okay, so let me just double check my notes and make sure I didn't forget anything. Yep. So now if you add all this up together, you get that T, which is equal to the work, is actually equal to 9 negative 0.72 joules. Okay.